Okay, so this is how it looks. We have been given the value of the acceleration. So they have said acceleration is equal to 3 meters per second squared. And they want us to find the value of v. So you can see v is right here. So we are looking for the speed. This is where v is. That's the speed we are looking for. Upon realizing that we've been given the acceleration, we just have to use the formula of finding acceleration. So this stuff or object was accelerating right here. You can see this is acceleration up to here. This side, it's a deceleration. So the formula for acceleration will look like this. A is equal to v minus u over a t. This is a very simple formula to remember. So down here, we know that here it's a 0. This is where it started accelerating. So we have to follow it all the way up to here where it ended accelerating. So the speed here was v. You can see this is straight with v. While this one, it's a 0. So this is our u, this is our final velocity. Initial velocity, u, final velocity, v. Time where it ended here, it's 4 seconds. So we just plug in our formula. We shall say v, actually we start with a. Do we have a here, acceleration? Yes, in the statement they said the acceleration was 3 meters per second squared. So this is our a. For v, we just write v minus our u, it will be 0 where it started from here, over the t will be a 4. So t is 4 seconds. So we solve for v, we shall have a 3 is equal to v here, because v minus 0, it's a v over a 4. So what is our v? We cross multiply. Okay, there's a 1 down here. 1 times v, it will give us a v, which is equal to 3 times 4, it's a 12. So this is 12 meters per second. Remember, the units for velocity or speed, it's meters per second, while acceleration is meters per second squared. So this is the value of v. So question A, the solution is supposed to be 12 meters per second. Let's go to question B. Okay, so for question B, we need to find the average speed for the first 12 seconds. So you can see this diagram here, 12 seconds is right over here. So to find the average speed, we definitely need the formula, which looks like this. Speed, let me write it here, speed is equal to distance over time. So this is the formula we need in order for us to find what? The speed. This is a key formula. Now, once we get to know this formula, we have to identify or to find d. Do we have d? We don't have d here, the distance. Do we have time? Yes, time is 12 seconds. So what will be the key thing to do here? The key thing will be to find distance. So let's do this. For distance to be found, we get the same diagram here. So this is what we've put down here. I just want you to understand something. That's why I've put up this diagram. So we need first to find the difference. Like, look at this formula. It has got A, B, and H. This is a formula we use when we want to find area over a trapezium. This is a trapezium, okay? So we use this formula. Now, this formula will help us find distance. So when you want to find area of a trapezium, you use this formula. The same formula, you use it when you want to find what? A distance. So we shall identify our A. So our A will be this length. From here, you can see this trapezium, it has got 2 parallel lines. There's this one and this one. This line and this are parallel to each other. So one of them will be our A. So let's say this is our A. Like from here to here, it's our A. What is it? From here to here, since it's our A, it's a 12. This is 12. So from here to here, it's 12. What about from here to here? We shall say this is our B from here to here. And what is it from here to here? This is 8. Now, where did I get 8 from? I'm just finding the difference between 4. You can see this is 4 and 12. So I'll just say 12 minus a 4, which will give us 8. So that's our B. Okay? So once we get to find our B there, we now find our H, this height. So the H will just be the difference or the distance from the B to the A to the B, meaning from here all the way up to the top line. So the difference or the distance from the baseline to the top line, which is a 12. So where did I get this 12? From here. It's from here to here, it's a 12. This is my 12. And that's my H. So now the job would just be to calculate. To do the calculations here, my A is what? Is a 12. Plus my B is a 8. My H is what? Is a 12. So now when we look at these brackets, this is multiplication. So we can have something like this. It's the same. This can be multiplied by this, and then we say times what is inside. I'm putting times here so that you people understand. The brackets themselves, they mean times. So I've just put the times so that you see the difference. So this will give us a 20 inside here, of which, since we are multiplying these to 12 over 2 times 20, remember, paper 1, you're not allowed to use a calculator, so you have to be very careful. This 2 can go into 12. It can also go into 20 if you want, whichever number that you want to divide it in. We can say 2 into 2, 1. Into 12, it's a 6. So what is 6 times 12? That is 120, if I'm not mistaken. So this times this, it's 120 meters. So we've found the distance. Distance in the what? First 12 seconds. So from here all the way up to straight with 12, this is a distance. So now we say speed is equal to distance over time. What is our distance? It's a 120 over what is the time? T. From here to here time is what? It's 12. So you divide by 12, and when you divide by 12, you're getting a 10. So our speed is 10 meters per second. This is the answer. 10 meters per second is our speed. Remember, the units must be put meters per second. For speed and velocity, it's meters per second. Okay, so let's check out question C and see what we're supposed to get on question C. All right, so for question C here, we need to find the value of t if speed at t is equal to 14 is 4 meters per second. So we're talking about the t being somewhere here, the time. So this t means time. So 14 seconds will be, of course, somewhere here. And the velocity or the speed here at t is equal to 14, it will be 4 meters per second. This is what we've been taught in the statement. And what is the speed at t is equal to 12? This is 12 meters per second, which is right over here. Okay, so we can transfer this information here so that we fully understand. So this is how it is. So this is where 14 seconds is. So once we get to understand this, we can just use the differences. We shall say t minus 12. T minus 12 over t minus 14 will be equal to, we want to use the differences like I earlier said. So t minus 12 over t minus 15 is equal to, now we start getting the speed. So which speed are we supposed to get first? Is it the bigger speed or the smaller speed? It's the bigger speed, which is 12. Of course, we started with the bigger length, which is from here to here, over from here to here, which we have right here. So even for the speed, we start with the bigger speed, which is a 12. It's a bigger speed over 4, which is the smaller speed. Of course, we can reduce here or we simplify. When we simplify, we're going to get a 3 because 4 into 4, it's 1. Into 12, it's a 3. So we'll get a 3. We can form a fraction here so that we cross multiply. We know that there's a 1 down here, which won't change anything. So it will be t minus 14 times 3. That will give us a 3. Okay, like this. Multiplication, brackets, they mean multiplication, which is equal to t minus a 12. So we solve the equation. This will give us a 3t minus 42. 3 times negative 14, that is negative 42, if I'm not mistaken. Yeah, which is equal to t minus 12. We group the like terms. This is what we are getting. This is what we are getting. So this will give us a 2t is equal to a 30. Divide by 2 both sides. So we have t is equal to 15 seconds. Because 2 into 2, 1. Into 30, it's a 15. So it's 15 seconds. So 15 seconds is our solution. In case you don't want to use this formula, this method, the method I've just used right here, you can use the disaggregation method, whereby you find the coordinates here, coordinates here, coordinates here, and use a disaggregation. That's how it is. Thank you so much for watching. Please remember to share the video. This has been Sichamba Jacob. And leave a comment in the comment section below. Bye-bye.